So the law of sines is one way to find missing angles and sides of any kind of triangle, a right triangle or even an obtuse triangle or an acute triangle. It works for any of them. So you can almost forget about SOHCAHTOA. However, often SOHCAHTOA is a lot easier. But so here's how the law of sines works. So when you're given any triangle and they label it like this, the angle is usually written as a capital letter. The side opposite is given the lowercase letter. So side A matches up with angle A. Side B matches up with angle B. It's across from it. And side C is opposite angle C. And then somebody discovered that if you take the sine of the angle, find that decimal for that angle, and divide it by the opposite side, that's the same for any angle side pair in the triangle. So to finish the law of sines formula, I'm just going to write the sine of angle B over side B is the same as the sine of angle C over side C. And that'll always work, and we only need to work it with two of these at a time. So it just is a proportion. You set it up, cross multiply, divide. And that's how easy it is. So now we're going to find that missing side. And notice I didn't give the angles any letters, but I always know that the sine of the angle divided by the opposite side is the same for any pair of angle sides. So I'm going to write the sine of 105 degrees over 81 is the same as the sine of 60 divided by x. And then because this is a proportion, we could go through and find the sine of that angle, write the decimal, and the sine of that angle and write the decimal, and then do that decimal times 81 divided by whatever that was. But we can just do this with a calculator. You can just on your calculator, you can just write, I would do 81 times, that's a button. If you're using little blue calculators, you can do sine of 60. Then you'll get a parenthesis, and then you can just hit equals. And it's important to do that equals because you want to follow the order of operations. Now, once you've got that, you're going to have some decimal number, and then you're just going to divide. So you can take that last answer, that whatever you just got, you're going to press divide by the sine of 105, and then hit equals again, and that will be the answer. And I'll do it on a calculator to see what we get. When I did this on my calculator, I came up with 72.6. So make sure you can get that on your calculator. Now remember, that's a distance. That's not an angle measure. That's not a degree. Okay, so why don't you try the next problem, and then stop the video, try the next problem, and you come back and watch me solve it. So I'm hoping that you actually tried this, not just watching it. So I see I've got angle, this 80 degrees is opposite my unknown side, and I know an angle of 15 degrees is opposite the 23. So the law of sines just says, hey, take the sine of 15 degrees, divide that by 23, and that'll be the sine as the sine of 80 over x. So on so what we do on our calculator, just do 23 times the sine of 80, and then press equals, and then you can divide by the sine of 15 degrees, and press equals again, and that'll get us the answer. And when I did this, I got 87.5. And remember, that's not a degree, that's a side length. That's how long this side is, if this side's 23 and all those angles match up. Now, if I wanted to, and I wanted to finish this off, I'm not asking you to do this, but you could find this angle by adding up these two angles and taking those away from 180, and then you could use another law of sines to find that missing side, and that's what's called solving a triangle. We're running out of time. I'm not going to ask you to do that this year, but you might in the future. So we also can use the law of sines to find a missing angle. And in this question that I created, we're looking to find how big that angle A is. So I know I've got this angle side pair. I know that angle goes with that side, so I can say the sine of 110 degrees divided by 81 equals the sine of angle A, which I don't know how big angle A is, over 20. So again, it's just a proportion. I can do 20 times the sine of 110. Then if you press equals, you can just divide that answer by 81, and then you're going to get some decimal number. Calculator, I got 0.2320. Well, that doesn't make sense that that's an angle size, so what you got to think about is, hey, this is actually what the sine of that angle is. So 0.2320. Now, if you did that quiz on Moodle, the very last problem was one like this. I said, tell me the angle if I told you this trig ratio. So the way you undo that is we're going to do the arc sine. And you did some skill practice work on that last skill packet. Some of you did. So I'm going to do the arc sine. So do second sine of that answer. And what do I get when I do this on my calculator? So I'm getting 13.4 degrees. So that angle right there is 13.4 degrees. And that kind of makes sense if you think about it, because this is definitely the biggest angle, because I can't have two angles that are more than 90. So this side has to be less than this side, which we know it is. So that angle has to be smaller than that angle. That's what you do. So you set up your ratio, you do the cross products, and then you got to do second sine. You don't have to worry about tangent and cosine here, because it's always the law of sines. Try that next problem. Watch my solution. So I'm looking for the measure of angle A. So I know the sine of 123 degrees divided by 39 is going to be the same as the sine of angle A over 10. So we're going to do 10 times the sine of 123. Press equals. Divide that answer by 39. And then whatever we get, we're going to second sine it, arc sine it. So when I did this on my calculator, I came up with, I went 10 times the sine of 123, hit equals, divided by 39. I got that decimal. I mean, that's a little rounded. And then I did second sine of that decimal, and I came up with that angle A is 12.4 degrees. Okay, and then that's how you do it. So now you're all set to do almost all that last page in the problem set, or a skill packet. And I'm going to have the answers up on danleme.net, so you can check your answers, make sure you're doing it right. The last two problems require the law of cosines, and we'll learn about that later.